Hi, everyone, and welcome to the Unit 6 review. Are you ready for this? It's the last one. So here we go. The Unit 6 review. So here the first one is identify the base, the argument, and the exponent in the equation. Then rewrite the equation in exponential form and solve for n. I think they're all n, right? Okay, or x, or whatever the unknown is, right? So here we go. So here's the base. Oh, there's no base. I already have a mistake. I'm just kidding. Remember, there's no base, which means that that is a 10. And argument, what is the argument? So let me just write over here on the left. So whenever you have this log, this is the base, this is the argument, and this is the exponent. It's base, argument. Does that have an E in it? Oh my goodness, I don't know. Let's not argue about that. An exponent. Okay, that's what that's going to be referred to as. Okay, you ready? And so argument here is n. So do you see? I'm just listing it out. Exponent is 4. So equation in exponential form. So we're going to just write it in exponential form. So if you need the triangle, use a triangle. Triangle is always great. So again, is 10. Remember, it's invisible there. N and 4. So it's giving 10 to the 4 power is equal to n. I always like to do this. That's the exponent, and this is what it's equal to. Okay, and then so let's just solve that. Well, what is n equal to? Is there work that you really need to do? Not really at this point. Just on your calculator, you just go 10 to the 4th power. Oop, come on. So you go 10 to the 4th power, or just write 4 zeros and a 1 in front, and you got your answer. Right, there we go, 10,000, see, 4 zeros and a 1 in front. And so this can be 10,000, just like that. All right, so that's what we're gonna do for the next ones. So the base here for number 2 is 2. And again, I would try these out first, like pause me and then do it. Or if you've downloaded the review packet, right, from Canvas, go do it. You can do that as well, right? And then just do the problem separately. That's how you practice it. Review and study. And the argument is 32. Exponent is n. So the equation in exponential form is 2 to the n power is equal to 32. Oh, I can't write anything, right? So how do we do 2 to the n is equal to 32? Well, honestly, what I would do is just go back to this original, right, and then just use change of base, right? Because I know that this is the same thing as log of 32 over log of 2, right? So you just go on your calculator and go, I'll put it over here. So log, here's log of 32, divide that by log of 2, just like that. 5, yay, happy days, right? Okay, I suppose you could have just figured that out just by looking at 2 to what power will give you 32? 5. Duh. But if you didn't know that, this is what you would do. There we go. This is what happens sometimes. I try not to go over these so you can like beforehand so that you can, when you see it, like this is like real. Like these are the, struggles that maybe you have, or you're like, oh wait, learn from my mistakes. Okay, so again here, base is n. Argument is 81 and exponent is 4. So the equation in exponential form is n to the 4th power is equal to 81. Again, if you want to use that triangle, I like the triangle of power. So remember, we're writing it exact n, 81, and 4 in that order, the way you see it, the way you write it. So n, 81, and 4. And then it will be n to the 4th power is equal to 81. And so yes, you can actually just think about it right here, or you can 4th root it, right? If you want to just go like all algebraic about it, you can just, well, it's n to the 4th. So let's just take the 4th root. And you would get 3. Yeah, so your answer would have been 3. Because 3 times 3 times 3 times 3 is 81. I don't know if you knew that. Next one. here we go. The base is 3. The n is, or the argument is n, and the exponent is 2, which means it's 3 to the negative 2 power is equal to n. Oh, should have written that here. So 3 to the negative 2 power is equal to n. If you remember anything about negative exponents, remember that's just like 1 over 3 squared. And what is that? It's 1 over 9. So there we go. That's all that's going to be, 1 over 9. Leave it as 1 over 9. Don't change that to decimals, because that gets kind of weird and tricky. All that kind of stuff. We don't want that. All right, so here we go. It says identify the base argument. Oh, this sounds very familiar, right? It says, and then rewrite the equation in logarithmic form and solve for n. Round to the nearest 10,000th place if necessary. So if we need to, round to 4 decimal places. That's 10,000th place. All right, again, base is 3. Argument here is 15. And exponent is what we would expect it to be, n. All right, because that's in the exponent position. And, oh, sorry, guys, this should have been write the equation in log form. Obviously, I did not change that. I'm a ding dong, but that's okay. We'll change it here. So hopefully you watch the video. All right, because you're like, it's already in exponential form. All right, and so again, if you notice, this is like the triangle right here, right? So 3 to the n is equal to 15. So we're going to go this way. This can be already here. So log base 3 of 15 is equal to n. And now what we're going to do is we're going to solve for n. So remember that this is the same as we can just use a change of base formula. So this can be log of 15 over log of 3. And we're going to calculate it out. So here's log of 15. Again, try this on your own calculator. You don't want the test day to be the first day you try this out, because you're going to freak out and you'll be like, wait. And you get 2.464, but then remember this, the 7 right next to the 9 is greater than 5 or greater, which means that that's actually going to be a 50. 2.4650. And please make sure you include the 0, so I know that you rounded 4 decimal places, just happened to round up to 0 or 10, I should say, but you know what I mean. All right, so again, right here, base is 5, argument is n, exponent is 4. We're going to write this in log form. So that's going to be log, what's my base? Base 5 of the argument of n is equal to 4. All right, so now if you notice right here, I'm not going to solve it through the log form because that's not helpful. But if you notice here, that's super helpful. It's 5 to the 4th power. What in the world is that? So we go just 5 to the 4th power, which is going to be 625. Whoa. So do you see how sometimes it's easier to solve it in log form, and other times it's easier to solve in exponential form? So depending on what we don't know, right? So here we did not know the exponent, so it was much easier to solve it, or the argument, I should say. We didn't know the argument, so it's much easier to solve it in exponential form. And if you look at on the left-hand side, we did not know we didn't know the exponent. And so whenever we don't know the exponent, what we do? Change the log form, right? And he'll tell us what the exponent is. Because guess what? Logs are equal to the exponent. Same thing. All right, and going on here, I'm going to just change this to log, because I did not do that originally. All right, so 2 to the n to the 2 power is equal to 49. So the base is 2. The base is n. I totally wrote n. I said 2. The argument is 49. And the exponent is equal to 2. And so this is going to be log base n of 49 is equal to 2. And you're like, well, I can kind of figure that out at myself. What squared will equal to 49? And you're like, well, there are 2 numbers, right? But remember, when we do it in the log form, we cannot have negatives. So we're just going to go with 7. Okay, we can't have base of -7. You don't have bases of negative numbers. So we're dealing with just the positive. And again, right here, we can just square root both sides. If you didn't know, right? Just square root both sides. And so look at 8. So 6 to the n power. So this is base 6. exponent is n, and the argument right here is 30. That's a 30 peoples. That looks like a weird 30 now. So again, it's log base 6 of the argument, which is 30, is equal to n. If you notice, remember, we don't know the exponent. So let's just do the log. So remember, we're doing log of 30 divided by log of 6. Change of base formula. And I'll just move this over here. So log of 30, divide that by log of 6. And that's going to give me 1.8982 about. And that stays as a 2 because that's less than 5. So 1.8982. All right, so far so good. Okay, so now we're going to go on, and we have 24 problems. We'll say thinking. But these are all the different types of problems that you could possibly face. So here we go. And it'll be good. I would try these out, try to think of like which method you would use. Okay. And if you want to skip around, you can skip around. It's up to you, but I will go in order so you can kind of skip around. Again, so I noticed that I have 2 logs on the left-hand side, so I'm going to just kind of condense those. So I have log of base 8 of, oh, these 2 should be multiplied. I'm just going to put the 7 in front just because I don't like my numbers in the back. I just don't. And this is going to be log base 8 of 77. So since we have logs on both sides, what I'm going to do is I know that my arguments have to be the same, right? So I'm just going to drop my logs and I'm just going to look at just the arguments because they have to be the same. So 7 times x plus 10 is equal to 77. What I like to do here is I notice that the 7, if I divide out the 7 goes into 77 evenly, right? So I'm just going to divide that first. Do you have to? Can you just multiply it out first? Yeah, 100%. That's not a big deal. I just like doing it this way. Personal preference. So then I would just get x plus 10 is equal to 11. And then what do I do from there? Subtract 10. And what do I get? X is equal to 1. Nothing to round. That's it. If I plug this back in, so 1 plus 10, yeah, that's going to be 11. We're good to go. Okay. And then I'm going to try number 10 now. I notice I have logs on 2 sides, so it looks like I'm going to be dropping the logs later on to, just compare the arguments. And I notice that this is going to be log of 4x squared, and then this is divided by 2 is equal to log of 72. So what do you notice? I can simplify this some more. So this is log of 2x squared is equal to log of 72. Now I'm just going to drop the logs right now because I have logs on both sides. The arguments have to equal each other. So I have 2x squared is equal to 72. Now it's just algebra stuff. Let's just solve for x. We're going to divide by 2 on both sides. And then we get x squared is equal to 72. How do we get rid of that square? Got to square root it, right? So x is equal to plus or minus. Don't forget the plus or minus. We got to check that, of course. The square root of 72. And we get 8.4853, right? Because that's 5 or greater. So 8.4853. All right, and so let's just check. Can we put the negative in there, right? If I know if I put a positive and square it, it'll be fine. If I put the negative and square it, remember squared is originally in the problem, so we're good. Okay, so it can be both. There we go, done. All right, number 11, what do we have here? Again, oh, this is a little bit different, but I notice I have 2 logs on one side, so I'm going to combine those. Always try to combine if I can, make it as simple as I can. So log base 4 of 8, and this is multiplying, right? So times x squared plus 1 is equal to 2. I'm going to simplify this a little bit more just to, actually, you know what? Let me change to exponentials. All right, I think I'm going to try exponentials. Oops, what did I do? So remember, that's going to be 4, and then 8 times x squared plus 1, and then up here is going to be 2. So I'm going to get an exponent 4 to the 2 power, which is equal to 8 times x squared plus 1. If I simplify all this, 4 squared, 16, is equal to 8 squared plus 8. In this case, I just multiplied it out. Do you see the one above, how I divided? I could have divided here because I know that 8 goes into 16 evenly, right? But I'm going to do it the other way just to make you happy. No, for those people who like to do it this way. So you can kind of see both if you decide which one you would prefer, and then you just make your decision as long as you get the same answer, right? Because either way is mathematically correct. And then so we're going to subtract 8 on both sides. And what do you get here? And so we're going to get 8 is equal to 8x squared. And then I'm going to divide by 8. You'll notice though that if you divide it out first, the numbers are smaller and usually a bit easier. I'm just saying, not that these numbers are that big anyways, but I'm just saying. So we get x squared, and then what we're going to do is we're going to square root both sides. Don't forget your plus and minus. And you're going to get x is equal to 1 and -1. I wrote it differently here too. Why not? Right? +1 and -1, right? And if we plug this back in here, can it be negative? I know it can be positive because +1 squared, positive, -1 squared again is still positive, so we're good. Either way is okay. All right. So taking a look at 12. Let's go with this number right here, this color. And then again, I see logs on one side. So natural log of 3 times x plus 2. We are multiplying because that's a plus. If you put the 3 in the back, it's not wrong. It's just looks weird because we normally just put the singular numbers in the front. And then I can't drop the natural log because there's no natural log on the right-hand side. That's like a big mistake. So make sure the only way you could drop logs, remember it's drop logs, not drop log, is if you have logs on both sides. If you only have logs on one side, you can't drop that log. That's illegal move because it's only on one side. You either drop it on both sides or don't at all. And if we can't, then we have to change to exponentials. Okay. And so what we're going to do is we're going to remember the base is e, right? So let me do my little triangle here. So here's e, and this is 3 times x plus 2. And this is the 3 on top. So this is going to be e to the 3rd power is equal to 3 times x plus 2. Now I'm going to, what do you want to do? You want to multiply it out? Let's multiply it out. So e to the 3rd power is equal to 3x plus 6. And what are we going to do? We're going to subtract out the 6. So we get e to the 3rd power minus 6 is equal to 3x. And then, oh, let's keep that the same. Divide that by 3. This whole thing divided by 3. So x is equal to, oh, technically I should say about, I suppose. There's my about equal to. So we'll take our calculator. I don't know what that is. And so we're going to go e to the 3rd power, tab out, minus 6. Here, I'm going to push equals, okay? Because if I don't, I'm going to need parentheses. And I don't want to put in parentheses. That's too much time, work, for me anyways, right? I know it's like 2 extra buttons, but I just can't do it. And so I have that. And then I'm going to divide this 14 point something, divide that by 3. Okay? So I'm going to get 4.6952, right? Because that one rounds up to a 2. So 6.6952. Because if you don't do it that way, so if you go e to the 3rd power minus 6 and then divide that by 3, right? On the calculator, it's only going to divide just the 6 by 3. So yeah, you're not going to get the same answer unless you put in parentheses. And I told you I don't want to put in parentheses. About minimal number of buttons I need to push. Right? So if you notice, do you see how that is way bigger? Yeah, that's what happens when you don't put parentheses in there. And that's why I just do the top part first, press equals or enter in this case, and then divide that by 3. Whatever that. See the ANS, that's the previous answer. So it takes that 14 and then divides that by 3. Just saying. That is my little tip for you. Next problem. All right, we're cruising along here. So problem number 13. Well, we have a little bit of things to do. What I'm going to do here is, well, you can, 1 second. All right, so there's actually 2 ways to do this, and I'll do both ways and you can kind of see which way you like better. All right, so the first way is to, okay, so we're going to rewrite this so that this, remember this is the exponent, so this is going to be log base 3 of p plus 4 to the 3rd power is equal to 9, right? And again, so since we can't drop the logs because there's only logs on one side, so we're going to write this as an exponential. So 3 to the 9th power is equal to p plus 4 cubed, right? And then so from here, what we're going to do is, well, I don't know what, well, whatever that is, well, we could put that in the calculator. But the way we, well, I mean, technically we can just use our knowledge of exponents right here, right? So if I cube root this, I cube root this, right? What is the cube root of 3 to the 9th power? P plus 4 right here. So, okay, if you remember, that's just 1/3. Let me just do it. We can do this by hand, but 3 to the 9th power. Remember, the cube root is the same thing as 1/3 power. Well, what is 9? Is power to a power, which means we multiply, right? So it's 9 times 1/3, which is actually 3 to the 3rd power, which is 27. But if you don't believe me, you're like, Miss Lee, I don't know about that. So here, let's take a look at this. So this is going to be 3 to the 9th power, right? 19,683. And now we're going to cube root it. So cube rooting, remember it's math, is the 4th one right there. So there's cube root and we want of that answer. So there's the answer right there. That's that 19,000 whatever. Enter 27, like I said. Okay, so that's what that would be. So we have 27 is equal to p plus 4. So again, here we just need to subtract out the 4. And we get p is equal, basically p is equal to 23. All right, and if we plug that back in here, 23 plus 4, yes, it's positive, we're good to go. All right, so here's the other way of doing it. All right, so this is like alternate universe number 2. And so I'm going to just copy this down. So 3 log base 3 of p plus 4 is equal to 9. Are you ready? Remember, this is a multiply by 3. So what we could do is just divide both sides by 3, right? That's how you get rid of 3. And so we get log base 3 of p plus 4 is equal to 3. You see how that goes? And then we're going to get, we're change this to exponential form. So that's going to be 3 to the 3rd power is equal to p plus 4. Do you see how this is a little bit simpler? So we cut all this stuff and we go right to here, which is nice. And then, so this is going to be 27 is equal to p plus 4. And then again, we subtract 4 on both sides and we still get p is equal to 23. Okay, so either way you do it, it's fine. All right, so whether you want to divide out that 3 first right here in that front, or if you want to bring it back, you know, use the properties and be like, oh, that's an exponent to that argument. Yeah, you can totally do that too. Either way, again, like you see, is okay. Just saying, there is a more efficient way. I always like to find those efficient ways. All right, so let's look at the next one right here. So, this plus 8 is not with the argument, if you notice, because they're not together. They don't have parentheses, so we do have to subtract this out. So please be aware, keep your eyes open. All right, so this is going to be log base 9 of negative 6b is equal to 2. So let's take a look. Let's change this to exponentials because we can't drop logs. Why? Because we don't have logs on both sides. So this is 9 to the 2 power is equal to negative 6b. That's a b, it's not 66. All right, and then all we need to do, well, that's going to be 81 is equal to negative 6b. And then we're just going to divide both sides by negative 6. Please don't say add 6 on both sides. A lot of people do that. I'm like, that's multiplying. So b is equal to 81 divided by negative 6. And it does say round to the nearest 10,000th place. So let's do, I don't know that particular one by my brain. So 81 divided by 6 is, 13.5. There it wasn't that bad. So we'll say b is equal to negative 13.5. Boom. So I wrote it in decimals because there was asking for decimals. So that's what it, would you be marked wrong if you left it like that? No, you're fine. But yes, I'm looking for a decimal form here. All right, a couple more to go. By couple, I mean 9. All right, keep on going. Okay, so let's try that trick that we did before because I kind of don't want to do this to the negative 6th power. We're not doing that. So I'm going to just divide this out. So negative divide by negative 6, divide this by negative 6. And what do we get? Log base 4 of negative 5x plus 7 is equal to 4. And then again, change that to exponentials. 4 to the 4th power is equal to negative 5x plus 7. And 4 to the 4th power is 256. Let's find out. 4 to the 4th power. Yeah, there we go, 256. Happy days. So I'm going to write it here. So 256 is equal to negative 5x plus 7. Now, back to Algebra 1 stuff. Yay. Subtract 7 on both sides. And so you would get 249 is equal to negative 5x. And we're going to divide both sides by negative 5. And what do you notice here? X is equal to whatever that's going to be, right? So it's going to be 249, divide that by 5, 49.8. So this one is negative 49.8. For me, I usually don't put the negatives in there. I just know that, oh, my answer is going to be negative because one of them is positive, one of them is negative. So for me, I would just add it in with my answer because I told you, I'm trying not to put in a lot of buttons to press. Don't like that. It's just me. All right. And then let's try it for number 16. Again, if you have not paused yet and you've just been watching like straight through, like beast moding, and you can't do that. You can't like just, I mean, you can, it's just, you're not going to learn very well. Like when it comes to a test, you'd be like, I don't know. It made sense when she was talking about it, but I don't know. So remember here, we're going to just divide out the 10. That's the easier way to go, as you can see. So log base 8 of negative 7x plus 3 is equal to 3. Oh, and just time out. If you look right here, that's x is negative 49.8, right? If you plug that back in, negative times negative is positive. So we know that this is going to work, okay? Because our argument is still positive, just saying. All right, so again, we're going to change this to exponential. You see how we're just always changing these to exponentials. So 8 to the 3rd power is equal to negative 7x plus 3. And then 8 to the 3rd power is something. 512. I'm going to just write it up here. So 512 is equal to negative 7x plus 3. We're just going to solve it like how we normally solve all these kinds of problems, right? It always goes back to Algebra 1 stuff. I will tell you that. That's true when you go to pre-cal, when you go to calculus, well, most of the stuff in calculus, but it starts off super complicated, but then when we simplify everything and reduce stuff and take out stuff and whatever, you end up doing like basic algebra stuff. So it never goes away. Again, right here, you're dividing out the negative 7 and you're going to get x is equal to. So that's 509 divided by 7, 509. Divide that by 7. And that's going to be 72.7 7143. So about 72.7143. I think that's what it was, right? 7143. Okay, good. So that this is an X. I don't know if you know that, but that's an X. All right. And then here, oh, we have some exponentials here now. What do we do? The same thing we've always done, right? So now that we have exponentials, we're just, well, I do know that I can change this 8 to be the same base. So 2 to the x minus 1 is equal to 2 to the third power, right? 2 to the third power is 8. And I know that, ooh, if I have the same exponents, that means I could drop my 2's, right? Just like how we drop the logs, I drop my 2's. And then I know that x minus 1 has to equal 3, right? That's what it has to equal to. And if we add 1 on both sides, we know that that x has to be 4. You know why? Because 4 minus 1 is 3. I know, crazy. There we go. If you're like, I didn't know that, then if you had done it with the logs, could you have done it with the logs? 100%. So again, if we do the triangle, remember this is going to be 2 to the x minus 1 is equal to 8. So this is going to be log base 2 of 8 is equal to x minus 1, right? And then what we would do here is we would just have to add 1 on both sides. So then we would have, there's my green. So log base 2 of 8 plus 1 is equal to x. I'm just going to put the parentheses around the 8 to show you, yeah, that plus 1 is like completely separate. So if we take this and we go log of 8, so we're doing the change of base formula here, divided by log of 2. You got to end parentheses there and then put plus 1. See, 4, same thing, right? Just one way is takes a little bit less steps than the other way. Either way is fine. If you did not recognize, oh, you could put these as same bases, that's okay. All right. If you're like, well, we haven't done that in a while, again, that's okay. All right. So if I take a look at this, I'm like, oh, this does not look great. Well, I do know, let me just tell you that this 340, well, I know that this could be 7 squared. So I'm thinking if I could do the same bases here, maybe I could do them here because this is still an exponential form. So I would try and get used to that. So this is 7 squared, right? So I'm thinking, well, what can get 7 times 3, 7 times what will give me 343? So 7 times 7 times 7. Let's do it 3 times. Haha, if you notice, that's 343. So it's 7 to the third power, right? So this is actually 7 to the third power. But remember, this is in a fraction, right? Which means that, boop, we have, that's a -3 right there. Yeah. And then that is to the a plus 3 power. Are you ready? This is going to be fun. So if you notice right here is power to a power, which means what do we do with those powers? You multiply them. So it's going to be -3a minus 9 is equal to 7 squared, right? You distribute that -3 to both of them, both the a and the 3. And then now we can drop the bases because, you know, the exponent, the bases are exactly the same. So we're going to just look at just the exponents. And again, algebra 1 stuff. So we're going to add 9 to both sides. Yay. And then -3a is equal to 11. And then what are we going to do? Divide both sides by -3. And then our answer is going to be, where's my green? There it is. A is going to about equal to, I mean, technically you can just leave this as -11/3, but I said around to nearest thousands, 10,000s place, right? So 11 divided by 3, 11 divide that by 3, and you're going to get 3.6, 6 bar, but 3.6667. So that last 6 gets rounded up to a 7 since the next number is going to be 6 anyways, right? And don't forget the negative. Thought I forgot it, did ya? All right, a couple more problems to go. 6 more to be exact. All right, we're almost there. All right, so again, we're going to be practicing this again. So notice that the 6, I can change this 36 to 6 squared. and that's going to be to the v minus 2 power. And this is 1/6. So how do we bring it up to the top? 6 to the negative 1 power, right? Yeah. Hopefully this will help you with your exponent properties, yes? And so if we notice this is going to be 6 to the 2v minus 4. Thought I was going to say 2v or not 2v. That is the question. So again, the bases are exactly the same, which means we can drop that basis and then just look at just the exponents. So 2v minus 4 is equal to negative 1. So solve for v. So add 4 to both sides. And 2v is equal to 3. And if we divide both sides by 2, what do we get? V is equal to 1.5. Exactly. Right, because it goes into 1.5 times. There we go. All right, so next one. Getting a little more complicated, but still fine. I noticed that a lot of my bases are 5, so I'm wondering, maybe I could change 125 to a base of 5, right? And it's actually 3 times. 5 times 5 is 25. But times another 5 is 125. Okay, so that's going to be 5 to the 3rd power times 5 to the 3k power is equal to 5 to the negative k power. Now remember, when we're multiplying the bases, what do we do with those exponents? We add them, right? Power to a power is multiply. When we're doing this, then we're actually adding them. So this is going to be 5 to the 3 plus 3k is equal to 5 to the negative k. And again, same basis means we look at the exponents. So it's 3 plus 3k is equal to negative k. And get the k's together. Let's do it. So subtract 3k on both sides. And you're going to get 3 is equal to negative 4k. And you're going to divide by negative 4. And what do you get? K is equal to negative 0.75. Exactly. Right? Yeah, 3 divided by 4. Put it in calculator if you didn't realize. All right, now, I can't change this 1 to a base 19, and it's plus it's adding instead of multiplying. So, and the 73, yeah, this is not going to work. So I need to find a different way. I can't find the same bases here. Well, I'm going to just get the exponential by itself. So I'm going to just subtract 1 on both sides first and see if I could get it any better. And I got 72. Okay, so now I'm like, okay, I can't get the same bases because 19 times 19 is not 72. It's a big number. And then so what I'm going to do is I'm like, ooh, logs. I can do logs. So let's change this to logs. We're going to go log base 19 of the argument, which is 72, is equal to 6p. I can do this. All right. And then, well, I know that once I get this part, if I divide this by 6, right, that'll give me the answer. So here we go. So this could be about. Let's do some calculator work here. So log of 72, divide that by log of 19. What is that going to be? 1 point whatever. And we're going to take that and we're going to divide that by 6. So divide that by 6. There we go. So it's going to be 0.2421. So about 2421. So 0.2421-ish. Okay, and if you don't believe me, put that back into the equation and see if that helps, right? And that'll get you the answer. Because it should give you about 73. It won't be exact just because remember we rounded this. It's not going to work. All right, so let's try that for this one. Ooh, yeah, it doesn't look like I can have the same bases. So again, I'm going to just get the exponential just by itself. So the 15 with the exponent. So I'm going to divide out this 5 first. So I got 15 to the negative 3x is equal to 7. Okay, I really can't have the same base now. Yeah, 7 is a prime number, and yeah, that's not going to work out. So again, I'm going to change these to exponentials. Haha, just kidding. Logs. So log base, my base is 15 right here, of the argument is equal to negative 3x. This looks very familiar. Just divide this by negative 3, right? And what do we get? X is going to be about numbers, about some numbers. Okay, let me, oh, come on. Okay, so here we go. Log of 7 divided by log of 15. Enter right there. And I'm going to divide that by -3. All right, that's going to be 0.2395. Yeah, it stays as a 5. So 0.2395. I believe that was a negative, right? Yep, negative. Happy days. Okie dokies. That's what we're going to do. So we've been doing, we got 2 more problems. What? Again, try these problems by yourself if you have not already been doing that. All right. Again, ooh, the 9s can't have the same basis. So, and plus we have this -2. Yeah, we definitely need to get rid of that. But maybe we get the same basis after that. Let's find out. So we get 9 to the 2 minus 2.8x is equal to 2 goes in 36, 18 times. Oh yeah, this is, we're not going to be able to do that. Because 18 is definitely not a perfect square or a perfect cube. Doesn't work. So we're going to, we can't do common basis, so we'll have to do logs. So this can be log base 9 of 18 is equal to 2 minus 2.8x. It's a little bit more, but still it's totally doable. So again, we're going to just subtract 2 on both sides. And we're going to be like, using the right colors here. So this is going to be log base 9 of 18. I'll just put the parentheses around there so we don't get confused with all the other stuff we're doing. Minus 2 is equal to -2.8x. How do we get rid of that -2.8x? Or we need the 8, we need the x, not the 2.8. So divide by -2.8, right? Divide by -2.8. And here we go. Are you ready? Let's write it with the right color. So x is going to be, so it's going to be log of 18. Divide that by the log of 9. And I'm just doing the top part, -2. And I'm push enter right now. Okay, remember it's the big number first, and then we do the log of 9. And then once we have that number, I'm going to divide that by -2.8, so -2.8. And you get positive 2.445. All right. And so that's what that would be about. And last one right here. Ooh, these just get pretty complicated, don't they? But it's not bad. Remember? So again, we have this exponential here and we want to get rid of this +9. Got to get rid of all the other stuff, right? So we can change to logs. And if you go 2 to the -5x minus 10 is equal to, what is that? 65? 65. And so that's going to be, again, changing to logs. Log base 2 of 65 is equal to -5x minus 10. And what do you get? Notice we haven't really dealt with quadratics. That's okay. As long as you know how to, if you've seen them, we're good, okay? But know that that's the thing. We're just going to add 10 on both sides. And we're going to be like, okay, log base 2 of 65 plus 10. Just going to put the parentheses around that one. Divide that by -5, or is equal to -5x. And my brain already did it. And now divided by -5. And then our x is equal to about numbers. All right, so let's try this out. So here's log of 65. Divide that by log of 2. Right there, right? We're going to add 10. Press enter, unless you want to do the parentheses stuff. Press enter, and then you divide that by -5. And you will get -3.2045. 3.2045. There we go. Ta-da! So if it's an exponentials, what would help you is probably simplifying out down to like just the exponential, like get rid of everything else, and then change to logs, right? And then solve for it, solve for x. And if you have like exponentials where you can have exponential on both sides, remember you can equate the exponents together as long as you have the same base. You need to somehow figure out how to get the same base. And if it doesn't look like you can do that, I mean, honestly, you can just still do the logs anyways. And then if you have the logs one, if you have logs on both sides, right? If you like, where is it? Like these guys right here. Like if you have logs on both sides, then simplify both sides and then drop the logs and then equate the arguments together. Or if you have like logs only on one side, what do? Simplify it out as much as you can and then change to exponentials. That's it. And then solve for x. All right. So I hope that was helpful for you. I will see you guys later.